Okay, so this is the second half of Lesson 1 in Unit 5 for A2. We're still reviewing monomials and polynomials. Now we're going to be adding and subtracting polynomials in this section. Well, when you need to combine terms, the first thing you have to do is get rid of parentheses. There's two ways to get rid of parentheses. You can do what's inside the parentheses and then drop them, or you can distribute the number that's outside. So we cannot do what's in here because the terms don't match. Now as far as distributing, what's on the outside of this parenthesis is a positive 1. So we're going to distribute it, but it's not going to change anything. I just don't want you to think that I'm just dropping parentheses because I want to. I have a reason. I have distributed. It's just distributing a positive 1 is not going to change anything. Same thing here. I have a positive, even though you can't see the 1, it's there. When I distribute it, now when I have plus a negative or positive times a minus, that's going to give me minus. So I'm just going to make that a straight minus. Everything else is going to stay exactly as it is. Now I'm ready to combine matching terms. I'm going to do this by order of exponents. That way it will be in standard form when I get through. So I'm going to start with my highest exponent. 3x plus x, or 3x squared plus x squared is 4x squared. 11x minus 5x is positive 6x. And plus 4 minus 13 is minus 9. There's nothing else that can be combined, and the exponents are in descending order, so it's done. Okay, now let's look at number 2. And here's our problem, and once again, we are adding. And there is no number in front of either one. So let's just say we're going to be able to drop the parentheses. So let's just start adding. There is nothing to add to the 9n cubed, so it's going to stay the same. All right, now as far as adding the n squared terms, I have a minus 4n squared and a minus 2n squared, and I'm adding, so that's going to be minus 6n squared. All right, 2n plus 1n gives me 3n, and minus 10 plus 7 is going to give me a minus 3. And that's as simple as it gets. There's nothing else to combine, and they are in standard form. Okay, for number 3, we're going to have to be careful because this one is subtraction. So nothing's going to change in this first set of parentheses. I'm distributing the positive 1 that's in front, even though you can't see it. So I'm just going to recopy it like it is. Now, when I distribute here, I am distributing that minus, the minus 1. So that's going to be minus 2k squared, minus 2k, and minus 17. It goes the opposite of everything. All right, now let's combine. There is nothing to combine with the 5k to the third. The minus 2k and the minus 2k makes minus 4k squared. Then plus 2k and minus 2k, that's 0, so I don't have to put anything down. And I have the minus 17 left. I always check back to be sure I've used every number and that everything's in standard form. Good to go. Okay, we see number 4 is also a subtraction, so we're going to be careful. Nothing is going to change about your first set. You're technically distributing that negative 1. Now when I distribute the minus, it's going to change everything. Right now this 1 is positive, but when I distribute the minus, it becomes negative. This is going to become a negative 2y squared. Now this is going to become a positive 5y and a positive y to the third. So that was the hard part. Now let's go through here and combine terms. I like to start with my highest exponent, so I'm going to take y to the third first. There's nothing that matches to it. So next is my y to the second terms. I have a positive 4 and a negative 2. So when I combine those, I'm going to get positive 2y squared. Remember, when you add and subtract, exponents never change. All right, next is the y term. So I have a positive 1y and a positive 5y. So that gives me positive 6y. Then I have, I don't know how many lines I'm at now. You notice I try to underline matching terms with the same number of lines. When I run out of room, I go to dots. All right, negative 3 minus 1 is negative 4. So I check to be sure that I've used everything, that my variables are in order according to exponents, so I'm good to go. Okay, number 5 says subtract this from this. So a little bit tricky there because they give you the numbers in inverted order. If I'm going to subtract this from this, well, this needs to come first. So I'm going to write 8b squared plus ab minus 2a squared minus everything that's in this parenthesis, negative 10ab plus 7a squared minus b squared. Okay, so nothing's going to change here. It's going to be 8b squared plus ab minus 2a squared. Now, I'm going to distribute that minus sign. So minus times negative 10 is going to be positive 10ab. And minus times positive 7a squared is going to be negative 7a to the second. Minus times negative b squared is positive b squared. All right. Now, when you put things in order, as we said, you want to go in descending order according to exponents. So what if there's more than one letter? Then you go in alphabetical order until you run out of that letter. So my first letter here is A. I'm going to put all the terms that have an A according to in descending order. And then I'll do a B if I have it left. All right. So the highest A exponent I have is a to the second. So when I combine minus 2a squared minus 7a squared, I get negative 9a squared. All right, my next is just going to be an A term. So here I've got positive AB and plus 10AB, so that's going to give you positive 11AB. And now that's all the A's, so next we go to the B's. Let's find the highest exponent of B, which is b to the second. So I have 8b to the second plus 1b to the second, so that's plus 9b to the second. And I'm all out of terms. These are in descending order, correct standard form, so I'm good to go. Okay, in this section we're going to be multiplying, and you really have to be paying attention in this section. This is probably the most complicated section. It's not hard, it just has a lot of steps to it. So what we want to do is we just want to make sure that everything in one set of parentheses gets multiplied times everything in the second set. So I want to be sure that W gets multiplied times all three of these things, and that minus 7 gets multiplied times all three things, and then we'll combine terms like we did in the first section. All right, W times W squared is W to the third. W times 2W is positive 2W squared, and W times 1 is W. All right, now negative 7 times W squared is going to be minus 7W to the second. Negative 7 times 2W is going to be negative 14W. And negative 7 times 1 is minus 7. All right, let's find our highest exponent, W to the third, and start with it. All right, now for my W squares, I've got a positive 2 and a minus 7. So that's going to give me minus 7W squared. Then I've got the plain W here, W to the first power, the linear term. 1W plus negative 14W is going to give you negative 13W. And then you have the minus 7. I check to be sure I've used every term. I look to be sure nothing else can be combined and that they are in order. And that's your answer. Okay, for number 8, we have negative 3 times a plus 5 times a minus 2 times a plus 8. Now, and even though this isn't in parentheses, you could put it in parentheses if that makes it easier for you to see. I've got 4 sets or 4 terms here that are multiplied together. And it doesn't matter which ones you do first. You can mix and match. When multiplication is commutative, that means you can move the terms around however you want to. So what I'm going to do is I'm just going to work my way from left to right. Remember, you can only multiply 2 numbers at a time, so just pick your 2. Now I'm going to distribute the negative 3 into here. And another thing, I see a lot of people a lot of times when there's one number out here, a monomial, they try to distribute it into each thing. No. Once you've used this, it's done. So when I multiply this, I'm going to have negative 3a, and that's going to be negative times positive 5 is minus 15. Now, that's done. So I have the other two to worry about, okay? And just do two at a time. I'm going to multiply this times this set of parentheses, and that means I have to be sure I multiply that times both things and that times both things. So negative 3a times a is negative 3a squared. Negative 3a times negative 2 is positive 6a. All right, negative 15 times a is minus 15a. And negative 15 times negative 2 is positive 30. Okay, so I have this. I also have the a plus 8. Now, I can combine these two terms in the center, and that's going to help me out just a little. So I'm going to go ahead and do that. I have negative 3a squared. Positive 6 minus 15 is going to be minus 9a plus 30 times a plus 8. Now, you can distribute this one backwards if you want to, or you can distribute these that way. You'll still get the same thing. All right, and I'll just stick with going left to right. So I'm going to make sure that I multiply this number times both of these, and this number times both of those, and then 30 also. So let's get started. That kind of made it look messy, but we'll keep up. All right, negative 3a squared times a is going to be negative 3a to the third. Negative 3a squared times 8 is going to be negative 24a to the second. Okay, I'm good. Now, negative 9a times a is going to be negative 9a squared, and negative 9a times 8 is going to be negative 72a. The 30 is going to be 30a and plus 240. Okay, now let's go through here and simplify. There are no more x to the third terms, so 3a to the third is going to stay like it is. Now, a minus 24a squared and a minus 9a squared you're going to add because the signs are the same. It's going to stay negative, so that's going to be 33a to the second. All right, a negative 72 and a positive 30. Since they have opposite signs, you're going to subtract. Your answer is going to have the sign as the highest number. So 72 minus 30 is going to be 42a plus 240. And I look to be sure that I have used everything, and I did. There's nothing else to combine, and it's in standard form. So we'll move on. Okay, for number 9, we have 2c plus 5d to the third power. Now remember, when you have a binomial, polynomial, whatever, raised to a power, you don't just distribute that power into the polynomial. What you have to do is expand it. So what we're going to do is 2c plus 5d times 2c plus 5d times 2c plus 5d. And just like with the other one, you can only work with two things at a time. So let's take the first two sets of parentheses and we're going to distribute. And you can call this foiling if you want to. It still just amounts to multiplying everything in the first set times everything in the second. So 2c times 2c is 4c to the second. And 2c times 5d is plus 10cd. All right, now our next one, 5d times 2c is also 10cd. Even though the d is first here, if you put them in alphabetical order, that's going to make it easier to see where you have a match. Then 5d times 5d is 25d squared. And we still have the 2c plus 5d to contend with. But before I do that, I'm going to go ahead and add these two together. So now I have 4c squared plus 20cd plus 25d squared times 2c plus 5d. All right, now I'm ready to distribute, and I can distribute this way or I can distribute that way. It's still going to be the same number of terms, whatever else. So I'm just going to go left to right. I'm going to multiply 4c times both of these, and 20cd times both, and 25d squared times both. So let's do 4c squared times 2c is going to be 8c to the third. 4c squared times 5d is going to be positive 20c squared d, and that takes care of the 4. Now 20cd times 2c is going to be 40c squared d, and 20cd times 5d is going to be 100cd squared. Now the 25d squared times 2c is going to be 50 and c d squared. Then 25d squared times 5d is going to be positive 125 d to the third. Okay, so let's carefully go through this long list of numbers and match up things that match. There is no other c to the third term, so 8c to the third is going to stand like it is. Now, this c squared d term matches this one, so 20 plus 40 is 60 c to the second d. All right, these two match because they're cd squares. So I can add 100 plus 50 and get 150 c d to the second, and then that 125 d to the third stays alone. Okay, so there you go. Okay, for number 10, we have a trinomial times a trinomial. So we just have to be careful and make sure that we get everything in here, all three of these multiplied by all three of these. So when we get done with the first step, we're going to have 9 terms. Now, what I do, if it's a very important, like on a test or something, what I do as a first step to make sure I have less to focus on is I go ahead and split this up. And you don't have to do this step. I'm just going to show you. I take the first term, 3m to the second, and then I multiply it, or I show that it's got to be multiplied times all of that. Then I take my second term, minus 4m, and I show that it's got to be multiplied times all of this. And then I take my third term, and I show that it's got to be multiplied once again times that whole second set, and that is an m, okay, and that's a 9. Okay, now an extra step, yes, but now all I have to do is focus on this, and if I start drawing lines on this one, it's going to make a big mess. But anyway, so 3m squared times 2m squared is 6m to the 4th. 3m squared times 5n is m is plus 15m cubed. 3m squared times negative 9 is going to be negative 27m squared. Now I can move to this one. See how it makes it a little bit easier to focus? So if you multiply negative 4m times 2m squared, it's going to be negative 8m to the third. And negative 4 times 5 is going to be negative 20m squared. And negative 4 times negative 9 is going to be positive 36m. All right? Now, since I'm distributing 1 all through here, it's not going to change. It's just going to let me drop the parentheses. So I've got 2m squared plus 5m minus 9. Okay? Now we're ready to go through here and combine all the terms we can. So let's look for our highest exponent, 6m to the 4th. And I'm going to cross that one off when I use it. All right, now our m to the thirds, what all do we have? I have a 15 and I have a minus 8. So that's going to leave me with positive 7m to the third. Okay, now my m to the seconds. Here I have a negative 27 and a negative 20, so that brings me to negative 47. Plus 2 more is going to be negative 45m squared. All right, the next thing is 36, positive 36 plus 5 is going to be positive 41m. And then that minus 9 stands alone. So I go back and check. That should have been 41. and I'm good to go. Okay, for number 11, we also have trinomial times trinomial. This time, I'm going to skip that middle step, that first step, so you can see the difference. But I am going to have to stay on my toes. So I'm going to multiply all three of these terms times all three of these, which means I should have 9 terms in my next step if I want to check myself. So x squared times negative x squared is going to be negative x to the 4th power. And x squared times minus 9x is going to be minus 9x to the 3rd. And x squared times minus 4 is going to be minus 4x to the 2nd. All right? Now for the 6x. 6x times minus x squared is going to be negative 6x to the 3rd. And 6x times minus 9 is going to be negative 54x to the 2nd. And 6x times minus 4 is going to be minus 24x. Now for the minus 7. Negative 7 times negative x squared is going to be positive 7x to the 2nd. Negative 7 times negative 9 will be positive 63x. And negative 7 times negative 4 will be positive 28. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we've got to go back and combine things. There's no more x to the 4th terms, so that's all I can do with it. Now let's go down 1 to x to the 3rd. I have minus 9, minus 6, so that's going to give me a minus 15x to the 3rd. All right, next I have my x squared terms. So I have this negative 4, and I have minus 54, so that's going to give me minus 58. And then I have positive 7, so that's going to give me minus 51x squared. Then I have a negative 24 and a positive 63x. So the signs are different. It's going to be positive. I'm going to subtract, and 63 minus 24 is 39x, and then I've got that 28 left over. Okay, number 12, we have a word problem. We need to find the area of a trapezoid. And the height of the trapezoid is 2x plus 9, and it has bases of 3x minus 7 and x plus 5. And just to review, a trapezoid looks like this. That's why the bases B1 and B2 look different, because one of them is longer than the other. All right, so that's the area. Now, here's your formula for area, and we're going to fill in these things, and then we're going to solve it. So let's just get started. Area is equal to 1/2. The 1/2 is non-negotiable. It's in the formula. So next I want to add B1 plus B2. It doesn't matter which one is 1 and 2 because you're going to add them together. So we're just going to put 3x minus 7, and let me put this in brackets, plus x plus 5. Another point of review, the difference between brackets and parentheses is nothing. You alternate them because it makes it easier to see what's grouped and what's not. So you can use brackets anytime you want to use parentheses. They're the same, they're equal. All right, now our height is 2x plus 9. So first, let's go in here and let's add these things. So I'm going to keep my 1/2. All right. There's a plus sign in here, so when I distribute it, nothing changes. So 3x plus x is 4x, and minus 7 plus 5 is minus 2. So now I have 3 sets of parentheses multiplied together. Remember, 2 at the time, pick your 2. I pick 1/2 times this, because both of these numbers are even, so I'm just going to be taking half of them. When I multiply 1/2 times 4, I get 2x, and 1/2 times 2 is minus 1. Okay, much more manageable now. I'm just going to multiply these two binomials together and add matching terms. So 2x times 2x is 4x to the 2nd, and 2x times 9 is plus 18x. Minus 1 times 2x is minus 2x, and minus 1 times 9 is minus 9. Combine these two terms will leave me with an answer of 4x to the second plus 16x minus 9. And that is the expression for the area of a trapezoid with the given information. Okay, our last section is on dividing polynomials. And what we have in this section, we have a polynomial over a monomial. Now, I do want you to understand when you have a polynomial on top and a monomial on the bottom, all of the terms, however many you have on the top, they share this denominator. You combine it to make it easier to write, but I want you to see what you actually have is 9m to the third over 3m minus 24m to the second over 3m. Every term actually has that denominator. So when you get ready to reduce, if you reduce the 3m with this 9m, you still have to reduce it with the 24. So sometimes separating it out like this, at least for a while, helps your brain, get a hold of that. So now when I reduce 9 over 3, 9 divided by 3 is 3. M to the third over m, you're subtracting exponents, so that's m squared. Then over here, 24 divided by 3 is 8, and m to the second over m is m. Okay, for number 14, we're going to divide a trinomial by a monomial. And once again, I am going to take the time to rewrite each term in the numerator over that denominator, because when I start striking through things to cancel out, it gets messy and I don't want to lose anything. Okay, now I just have three simple fractions to reduce. 20 over 4 is 5. X to the third over x is x squared. Right here, the 4's cancel out, that's 1. X squared over x is just x. And then over here, the x's cancel out, and 8 over 4 is 2. It's as easy as that. Okay, so here's number 15. Now this one is multiplication. What's it doing in the division section? But then when you look down here, this 2a is raised to what power? To the negative 1. So a negative 1 means you have to flip it. Now remember, everything is actually over 1, so when you flip this, it's going to be 1 over 2ab, and then when you multiply it, that's going to become your denominator. So what I'm fixing to do in this next step, I am going to split it up, and I'm going to do this all in one step. So now I'm going to put this over 2ab minus. All right, now I have 20 a squared b squared over 2ab plus 2ab over 2ab. Okay, so I hope I didn't lose anybody. The negative 1 caused me to flip this. 2ab became the denominator of this whole thing, so then I just split it up into 3 smaller terms. Okay, now we're just going to reduce. 14 over 2 is 7. A to the fourth over a is a to the third, and b to the third over b is b squared. All right, 20 over 2 is 10. A squared over a is a, b squared over b is b, and 2ab over 2ab is just 1. Okay, for number 16, we have another trinomial divided by a monomial, and yes, I'm going to split it up one more time. I know it's annoying to rewrite a step over like this, but I'm going to tell you, this prevents so many careless mistakes that I think it's worth it. If you don't want to rewrite it, if you want to try to do it all in your head, go for it. All right. And I hope I didn't make any transposition errors. It's a lot harder doing this when I don't have helpers in my audience. Okay, so now let's just reduce each one. 30 and 12. Well, both of those are divisible by 6. So when I divide that by 6, I'm going to get 5 over 2. All right, c to the 8th over c to the 2nd, subtract exponents and put it where the largest exponent is. So that's going to be c to the 6th on top. And then d to the third over d, subtract exponents, put it up here. So that's d squared. My next one, 36 over 12. Well, 12 will go into both of those. That'll be 3 on the top. And c to the 6th over c squared is going to be c to the 4th. D to the 2nd over d is just d to the 1st. Now my last term. I have 6 over 12, so that's going to reduce down and the 2 will be on the bottom. C to the 3rd over c squared will leave me c on the top, and the d's cancel out totally. So that's your final answer. Okay, for number 17, we have another trinomial divided by a monomial. So yes, I am going to split it all up. I'll go off to the side this time. So I'm going to have 30x to the 3rd over 3x squared minus 12x to the 2nd over 3x squared plus 9x over 3x to the 2nd. Okay, reducing down. 30 over 3 gives me 10. X to the 3rd over x squared leaves me x. Right over here, 12 over 3 reduces to 4. And the x squares divide out to 1, so you don't have to put that. Then 9 over 3 is 3. And x over x squared, now our largest exponent is in the denominator, so that x is going to remain in the denominator. So that's how that cancels out. And we're at number 18, which is our last one for this lesson. So let's take this and let's split it up. I'm going to do 40 m to the 3rd, n to the 4th over 8 m squared n to the 5th minus 24 m squared n to the 7th over 8 m squared n to the 5th. All right, let's reduce. 40 over 8 is 5. M to the 3rd over n to the 2nd, subtract exponents, put your answer where the largest exponent is, it's on top. Now, I've got n to the 4th over n to the 5th. If I still subtract the small number from the large one, 5 minus 4 is 1, but I'm going to put it where the largest exponent is, okay? So that's why n goes on the bottom, but m stays on the top. All right, over here, 24 divided by 8 is 3. The m squares divide out to be 1, so I lost it. N to the 7th over n to the 5th, you're going to subtract exponents. 7 minus 5 is 2, and it stays where the largest exponent is. And that is your final answer, and that is the end of lesson 1.